back to another topic, which is coding versus programming, and we'll learn much more further about how we could create effective programs. So coding versus programming. What do you think is the difference between coding and programming? I mean, don't they mean the same? So coding is basically writing our idea of code into the programming language interface, and programming is writing meaningful code to develop a software. Just to understand much easily, coding is learning the alphabet, and creating words. But programming is using those words and creating a meaningful book. So before we move on to forming a pseudocode, we will learn a few more things before that. So a logical approach is always applied in mathematics, where we write the variables and whatever value that it has. Then we apply the required formulas and find the answer. So let's have a look at an example to find the area of a triangle. So in such questions, we find that the value of the base and height. So in the triangle that is given over here, we have the value. We have a triangle. We have the value of the base. We have the value of the height. And also we would have to keep in mind about the values that we're dealing with and its limits as well. Because if the value of the base is 0, we would have a straight line. And even if the value of height is 0, we would again have a straight line. So just imagine. And the next step would be to find our logic or the formula to find the area. In late Middle English, the term pseudo was formed, which means false or not genuine or fake. So this code is not might not be genuine, but it is going to give us a lot of clarity about the method we are going to apply to solve the problem. So right here that we see is a flowchart, which is more of a pictorial representation of our pseudocode. So when we begin our pseudocode, we're taking a simple example of a program to ask if it is raining or not. So the program is asking if it's raining and if it is. And based on the answer that we give, if it is a no, we would leave the umbrella at home. And if it is a yes, we would take the umbrella. And the program ends. So this is a pictorial representation, but we'll be learning how do we write a pseudocode. So we'll be taking a problem to find the greatest between three numbers. So if I give you three numbers in an order of 15, 10, and 5, we would mentally compare 15 and 10 and find out which is greater. And we would compare that number with the third number to find out which is greater, right? So in that order, for a program, it would perform that way. And similarly, if we would give it in the following order of 10, 15, and 5, the program would check with 10 and 15 first, and then compare it with 15 and 5 to find the greatest number. So before we move on to writing a pseudocode, there are some rules. There are rules to everything, so let's have a look at that. So the rules of the pseudocode is that we begin the pseudocode with start. We initialize the variables, and we would test its limits, just like how for the area of triangle we need to make sure that the value of base and height are greater than 0. So that's why we would test its limits. And then the conditions should be written in simple terms like is equal to, is not equal to, is greater than, is lesser than, and so on. To display, we need to use the command write. And if you want to display text, it should be enclosed in double quotes. For calculations, we can use arithmetic symbols, the same greater than, lesser than, equal to, and addition, subtraction, so on. We would end our pseudocode with stop. So this is our first pseudocode. Before we move on to comparing between three numbers to find which is the greatest, let's start with something much simpler. So we'll be finding the greatest between two numbers. Our pseudocode would begin with start. We would initialize variables a and b as integers. I hope we are well aware what integers is all the negative and positive numbers together are integers. So we would read the values of a and b. That is, we're going to take the input of the value a and b from the user. We'll be checking now that if a is greater than b. If it is greater than b, we would write or print or display that a is greater. If this condition is false, we would check with the next condition if b is greater than a. So if this condition is true, then we would display that b is greater. And if this condition is also not satisfied, then we would display that both the numbers are equal. And that's the end of the pseudocode for this one. So on our right, we also have the pictorial representation, our flowchart, to depict how the flow is. So we had seen the simple one is the greatest between two numbers. Now let's have a look at greatest between three numbers. So once again, our pseudocode would begin with start. We would initialize variables a, b, and c as integers. We would read the values or take the input of a, b, c. And the first condition is that we would check if a is greater than b. And if a is greater than b, we would check with the third number that if a is greater than c. If it is true, then we would display that a is greater. And if it is not, we would have to display that b is greater. Sorry, c is the greatest. Else, if b is greater than c, if the first condition is not satisfied, we understand that b is greater than a. Third, and the next condition we would have to check is that if b is greater than c or not. So if b is greater than c, then b is the greatest. And if b is not greater than c, then we would have to display that c is the greatest. And then we would end our pseudocode. So now we'll move on to a few advanced. So I would like all of you to pay full attention to this. This might be much more tricky. So we'll be dealing with sequence and series. Sequence and series is basically an order of a type of set, numbers. We'll be dealing with numbers this time. So sequence and series would be the collection of numbers in which are arranged in a certain order. We have an order of positive numbers, as we see that 1, 2, 3, 4, 5, 6, etc. And then we have negative numbers, -6, -5, 2, -1. And then we have our integers, as we had learned before, that you can see on this slide right now. So we'll be dealing with integers mainly. So given here are three series that we can see in the slide. The first series is pretty simple to understand, that this is a series of even numbers. We have 2, 4, 6, 8. Their difference is 2, and if we divide it by 2, then we would get 0 as our remainder. So these are even numbers. That's the first one. The second series that we see is, of course, odd numbers. And the third series that we see is quite different than many other series. It's a special kind of series called the Fibonacci series that we'll be learning about today. So there's something new. So how Fibonacci series works is that the third element or the next element of the series is the addition of the previous two elements. So we see that the first element is 0 over here, the second element is 1, and the third element, which is 1 again, is the addition of 0 and 1. So that's how the series goes. So we'll be forming a pseudocode of um, of the following three series. So let's begin. So our pseudocode begins again with start. We would initialize a, b, and x as integers. We would be setting the so what we'll be working on, what number we'll be displaying is a. The value of b is the limit we are going to set, because if we want, so we can even create series of 5 elements or 50 elements or 100 elements. So we would be using the concept of loop over here. As you can see, repeat, right? So in pseudocode we use the term repeat for creating loops, because if we want to display 5 elements, it's easier to initialize 5 variables and just print all of them by setting its after setting its value. But if you have 100 elements that you want to display, it's going to be a very cumbersome task to set and initialize all the variables and set its values and set a print statement for them. So it's going to take very long. So that's why we use the concept of loop over here, which is going to make it much more, which is going to make your program much more efficient, and it is much easier to perform. So let's understand this concept. So we'll be setting our initial value as a is equal to 2. The variable x is going to be our iterator, because in the loop we would have to set a limit, right? For every increment of our loop, we would have to update its value. If we do not set an increment, it's going to be an infinity loop, right? So we would read the value of b because to set its limit. Now we would repeat the following steps until the value of x is equal to b. For now, the value of x is 1. So now the loop begins. We would write the value of a. So the value of a is written, which is 2. Now the value of a is increased by 2. So now the value of a is 4. And the value of x changes to 2 right here. So now the loop becomes, takes place once again, because the value of x is still not equal to b. Now, since the value of x is 2, uh, now the value of a in the previous step had become 4 right here. So now the value would be displayed as 4, and then the value of a is increased to 6, and the value of x is increased to 3. So that's how the program keeps flowing until the value of x is equal to 5. So when the value of x is equal to 5, the value of a becomes 10, the value of a is increased to 12, and the value of x increased to 6. But then it wouldn't repeat after that, because the value of x is, it has now exceeded the value of b, which is 5, and then our program would end over there. So the final answer that we would have is 2, 4, 6, 8, 10. And we'll be seeing only these values because we had set the limit as 5. If we had set a higher value, we would be having more numbers. So the next pseudocode right here that we see is the pseudocode for odd numbers, and it works pretty much the same way. The only difference is that over here we would set our initial value as 1, because we know that odd numbers also increment with the value 2, but odd numbers begin with 1. So it works pretty much the same way. The value of x is 1, we would display 1. The value of a increases by 2, and the value of x increases by 1, and it would go on until the value of x is equal to b, and after that program would stop. So since we'll also be displaying 5 values as we had seen, and the 5 values are displayed. And that's the end of this pseudocode for odd numbers. Now we look at one of the hard pseudocodes, which was created. Just a moment. Oops. Okay, so now we'll be doing the pseudocode for the Fibonacci series. We would begin our pseudocode with start. We'll be dealing with 5 variables over here, that is a, b, c, n, and x as integers. Now n would be our limit variable, just to display how many variables that we want to display, right? The value of a and b would be 0 and 1 respectively, and the value of x is also 1. X is our iterator for the loop. So now we read n. We have set the value of n as 5. Now we display the values of a and b. Now why are we doing this earlier? Why are we not doing in the loop? Because for Fibonacci series, 0 and 1 are the very important first two values. So I've also written it over here in the side, because it might get slightly complex later. So the value of a is now 0 and value of b is 1. Now we would repeat the following steps until the value of x is equal to n. So now c is equal to a plus b. So now we see that x is equal to 1. The value of a is 0 and b is 1. C is equal to a plus b. So 0 plus 1 is 1. So we would display our third element for this step. We would display our third element as 1. And now what is the most important step of the Fibonacci series pseudocode is that we have to switch values. So now the value for the next increment is that value of a becomes b, and the value of b is now c. So for the next increment, the value of a becomes 1 and the value of b becomes 1. So, and of course, as our increment variable x, the value becomes 2. And when we get to the loop again, the value of x is now 2. So this is our value a, this is our value b. We would add them up and display for this step the value of c is 2, and then we would again switch. The value of a would be taken from the value of a would be taken from b, and the value of b would be taken from c. So the updated values for the next increment would be a is equal to 1 and b is equal to 2. So this is how the process of the Fibonacci series goes on, to to display the Fibonacci series, and it would go on until the value of x is equal to n, and it would display it for the last time, and it would stop. So Fibonacci series for some people might be complex, but the pseudocode, it's easy to understand for us, but to write it down in pseudocode or even normal code is not a very easy task at times. So this is a concept which you might be learning when you get into college, and if you are already in your college, so this is just another explanation for you guys so that you have a bit more clarity when you get into your coding. So to conclude, we have seen a few main domains under computer science and how we are supposed to write a pseudocode. We have noticed that the pseudocode applies a logical approach for problem solving, and many other problems of yours can be analyzed by such logical approach. We need to look forward to our further studies, what college we want to get into, how much effort we need to put into preparing for the entrance, understanding the paper pattern, the time limits for each section. So there's a lot of pressure that we're dealing with. A logical approach, a properly planned approach, can help you much more than just getting into college or getting your dream job, but for any other stage in our life. So consider this as your takeaway from this session.